Welcome to Textbook Engineering Problem, where we explore complex engineering problems and discuss different methods for solving them. In this video, I'll be breaking down a problem and discussing different ways to tackle it. However, keep in mind that there is no one correct path for some of these solutions, and I encourage you to share your own insights and thoughts in the comments. Together, we can learn and improve our problem-solving skills. So, sit back, grab a notebook, and let's dive into today's problem. Today we're working out of Elementary Principles of Chemical Processes 3rd edition, and we're doing number 3.36. The problem statement says, the Great Boston Molasses Flood occurred on January 15, 1919. In it, 2.3 million gallons of crude molasses flowed from a 30-foot high storage tank that ruptured, killing 21 people and injuring 150. The estimated specific gravity of crude molasses is 1.4. What were the mass of molasses in the tank in pounds mass and the pressure at the bottom of the tank in pounds force per inch squared? Give at least two possible causes of the tragedy. Okay, so they gave us the volume of the tank, and they gave us the height of the tank and the specific gravity. And that's enough to answer these two questions about what's the pressure at the bottom of the tank and the mass of the molasses, total mass of molasses in the tank. Okay, let's start off with the mass. So we know mass is equal to density times volume. So all we have to do is multiply the density times the volume and then do the unit conversions. And we're left with pounds mass. Okay, and then for the pressure, this is our equation for pressure. We have a certain PSI, atmospheric pressure, P naught, and then we have our density times gravity times height here, and then the unit conversions in order to turn that into PSI, and then we're left with atmospheric PSI and then the PSI of the tank at the bottom, 32.9 PSI when we add both of those together. Okay, and then it says estimate two possible causes why this accident might have happened. Well, if the tank ruptured, that means the tank wall failed. The tank wall could fail because they were operating outside of the design, or because the tank was not designed for the operation it was handling. So the tank wall thickness maybe wasn't thick enough for the amount of volume that they were putting into it, or maybe the tank corroded over time. I don't know how long the tank was in operation, but maybe over time, if they didn't do regular maintenance or checks on it, then it could have failed because of that, that the thickness became smaller over time and fell outside of the design criteria. Something else that could have happened is, I don't know if they have other industrial equipment that was being operated next to the tank, but it could have been that, let's say somebody's driving a forklift and then they slash the tank with the forklift on accident, and then all of a sudden you have all that 32.9 psi of pressure spilling out of the tank very rapidly. So those are some potential design or operation fails that could have caused the accident to happen. All right, that is it for problem number 3.36. Thank you for watching, and I hope you found this video helpful in your problem-solving journey. Remember, there are other routes you can take to arrive at the same correct answer, and I encourage you to leave a comment with any additional insights or questions you may have. Also, if you have any specific engineering problems you would like me to cover, please let me know in the comments. Your feedback is valuable, and I look forward to continuing the conversation with you. Don't forget to like and subscribe for more engineering problem-solving videos. Thanks again, and I'll see you in the next video.